Alright, so let's talk a little more about sine and cosine as functions. This stuff will be important in the next section when we graph, but it's worth talking about. So, like any function that has a domain and a range, the domain is what you plug into the function, and the range is what it equals. So if f of x is equal to the sine of x and g of x is equal to the cosine of x, the domain is going to be angles. So you plug angles in for x, and then what these equal are going to be ratios. So our range is going to be ratios. Right, so like the sine of 30 is 1/2. You plug in 30-degree angle and you get a 1/2 as your ratio. Alright, so the domain of sine and cosine are all real numbers because you could plug in any angle from negative infinity degrees to positive infinity degrees or radians, and sine and cosine are defined for those angles. The range is in between 1 and -1. Alright, so the sine of an angle and the cosine of an angle cannot be greater than 1 or less than -1. Alright, and that kind of makes sense if you think about it. Like if we took a point xy, so let's say this point was at like 1, 1, and so that's root 2 units away from the origin. So the sine of theta would be 1 over root 2, which like is around, I think, 0.7. I could be wrong, but it's definitely not bigger than 1 because root 2 is bigger than 1. Now the biggest that sine is going to equal is 1 because when you have this point at 0, 1, that's going to be 1 unit away from the origin. So the sine of that angle would be 1. So the sine of 90 would be 1 over 1. And that's the biggest that it could be because the y-coordinate can never be bigger than the distance that that point is from the origin. Okay? So the sine and cosine of angles can only equal things in between 1 and -1. Alright, another thing about sine is that sine is an odd function. So you may have learned about that in algebra too. Alright, odd functions means that f of -x is equal to negative f of x, which means if you change the sign of what you plug in, then you'll get the opposite answer. So that means like the sine of -30 is equal to negative the sine of 30, alright, and that's degrees. Actually, it wouldn't matter, but we'll use degrees. Because the sine of 30 is 1/2, so that's -1/2, and the sine of -30 is -1/2 because it's in quadrant 4 in a 30-degree reference angle. So this property is true for all values that you plug in for sine, because sine is an odd function. Another thing about odd functions, graphically they have rotational symmetry about the origin. So if I were to graph sine, it would look like this. Right? And it has symmetry about the origin because if I were to rotate this 180 degrees about the origin, it would map onto itself. Alright? And that's because like for this point up here, like this point x comma the sine of x, there's going to be another point down here, negative x equals like negative the sine of x. So for cosine is even. Alright, even means no matter what you do for the input, the output's going to be the same sign. So that means, okay, like the cosine of 45 is going to equal the cosine of -45. So if you change, if only thing you do to the input is change the sign, it's not going to change the output. So the cosine of 45 is root 2 over 2. The cosine of -45 is also root 2 over 2 because cosine is positive in quadrants 1 and 4. So, and they're the same reference angle. So no matter what, as long as these are opposites, you'll get the same output. Alright? And graphically, even functions have symmetry along the y-axis. So that means that if you were to graph cosine, and we'll do that later on in sections, if you were to reflect this over the y-axis, it would reflect onto itself. Alright, so why does this help? I mean, it could save you like a step when you're evaluating functions of negative angles. So here we're going to practice using even and odd properties to evaluate sine and cosine. So since cosine is even, that means that the cosine of -210 is equal to the cosine of 210. Okay? That's just using this property of an even function. F of -x is equal to f of x. Alright, so now I could just figure out what that is. So that's going to be an angle in quadrant 3 with a 30-degree reference angle. Okay, cosine is negative in quadrant 3, so that's going to be negative root 3 over 2, because the cosine of 30 is root 3 over 2, and it's in a negative quadrant. All right, and we could check our work by actually doing this. So negative 210 would be an angle with a 30-degree reference angle in quadrant 2. So since it's a 30-degree reference angle, the absolute value of our answer will still be root 3 over 2. But because it's in a negative cosine quadrant, it's going to be negative root 3 over 2. Okay, with the sine of negative 315, you could rewrite this as negative the sine of positive 315. So if you were doing the sine of 315, that's a 45-degree reference angle. So the sine of 315 is equal to the sine of 45. Well, they have the same absolute value. They're not equal. So the sine of 45 is root 2 over 2. All students take calculus. So in quadrant 4, where 315 lies, terminates, sine is negative. So it's going to be negative root 2 over 2. So negative, the sine of 315, would be negative root 2 over 2. So that's positive root 2 over 2. All right, and you could check your work by just doing this directly. If you drew a negative 315-degree angle, it would end up being a 45-degree angle in quadrant 1, which would give us the answer of root 2 over 2.